Hi, this is John with the DSPIRA group. In this video, I will be describing for you the user interface output of the Gnuradio program Spectrometer with Cal that we use with our horn radio telescopes. You can see I have a horn set up, pointing up at the sky, of course. Feeds into the computer, and on the screen here you'll see the Spectrometer with Cal canvas before we run the program. When we run the program, the first window that pops up will be what I'm showing here, and it is showing the graph of signal versus frequency, and that's the spectrum we want to be studying. Looks pretty flat here. There might be a little bump here, and so I'm going to describe for you briefly some of these features. The first thing we have here on the left is the Y min and Y max. Since we're kind of down, I can zoom in a little bit. Okay, and you can see that this feature here seems to be getting a little bigger. I can even zoom in with my minimum there. The various display options I have here are shown in this box. Right now it's on Unfiltered Spectrum with no calibration. That's the most common box you could use, or the spectrometer with calibration, which is the second box. That box is what you'd be displaying after doing a hot calibration and cold calibration. I will not be discussing those in this video. The option at the bottom, the unfiltered spectrum, is just that. It is unfiltered, and if you see here, it also has a couple features that we didn't see in that first graph, and that is that we have this sloping up thing here and then this big peak at the end. Those are artifacts of the digital signal processing system, and when I'm showing the spectrum to my students, those tend to be a distraction, so I like to eliminate those. In addition, it's nice to have a filtered spectrum. So if I go back to the filtered spectrum with no calibration, you can see that it's a lot smoother. And it also clips off the ends. Full or clipped spectrum options are shown here. The full spectrum just shows exactly that, and you can see those distracting features reappear. When I clip it, they go away. So that's the preferred screen I like to be looking at. The integration time here can be adjusted with a short integration or long integration. Right now, that short integration is 0.4 seconds. If I click to the long integration, which I think right now is set at 10 seconds, you can see that the data is very much smoother. And that's real nice. This peak here is definitely noticeable now. If I want to save my data, I have two options here. I can write continuously to a CSV file. So if I click writing the file, every time an integration occurs, that a file, the spectrum, will get output to a text CSV data file. This is useful if you're doing, say, a drift scan map, or if you want to do an observation but you can't be available when the object is actually going to be appearing. The other option you have is to capture the screen. If I pop this button here, it'll quickly write what's currently on the screen to a data file, and that's also very convenient when you're doing certain types of observations. The graph on the far right here, this little, what we call the system heartbeat, is actually a histogram of the input signal to the Gnuradio program, and it's not really of importance to us other than the fact that it's jumping around. If that signal graph ever stops jumping around and it looks very still, that means this program is probably not collecting data, so that's not good. Other options I have here are this azimuth box, elevation box, and anytime box. These are text boxes that I can enter values. For instance, if I'm at an azimuth of, say, 210 degrees, I put it in, I have to hit enter. If I don't hit enter, it won't get recorded. Maybe I'm at elevation. Right now it looks like I'm at about 80 degrees. And then right now I'm in Morgantown, West Virginia, at the University of West Virginia. So I type in Morgantown and hit enter. If I do that, when I save my data by capturing it or writing to file, which it's doing right now actually, this information appears in the heading of the file name, or in the file name itself actually, as well as the timestamp. So those are very useful features. The only other thing I'm going to mention right now is that there's another tab up here called Systemp and Gain. These are useful when you're actually doing a calibration. I will be describing a calibration in a different video, but for most uses, what I've just described is what you need to know. See you at the next video.